Dear chemistry aspirants, right now the hybridization is a topic here, and this topic will come under the chemical bonding and molecular structure. And when you study, then you will see, in order to explain the characteristic geometrical shapes of polyatomic molecules like CH4, NH3, and H2O, etc. Pauling introduced the concept of hybridization. According to him, the atomic orbitals combine to form new set of equivalent orbitals known as the hybrid orbitals or orbitals. Unlike pure orbitals, the hybrid orbitals are used in bond formation. The phenomenon is known as the hybridization, which can be defined as the process of intermixing of the orbitals of the slightly different energies so as to redistribute their energies, resulting in the formation of new set of orbitals of the equivalent energies and shape. For the example, when two second s and the 2p orbitals of the carbon hybridize, there is the formation of four new spq hybrid orbitals. Salient features of hybridization. The main feature of the hybridization are as under: the number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. The hybridized orbitals are always equivalent in energy and shape. The hybrid orbitals are more effective in forming stable bonds than the pure atomic orbitals. These hybrid orbitals are directed in shape in some preferred direction to have minimum repulsion between electron pairs and thus a stable arrangement. Therefore, the type of hybridization indicate the geometry of the molecules. Important conditions for hybridization: the orbitals present in the valence shell of the atom are hybridized. The orbitals undergoing hybridization should have almost equal energy. For promotion of electron is not an essential condition prior to hybridized. It is not necessary that only half-filled orbitals participate in hybridization. In some cases, even filled orbitals of valence shell take part in hybridization. Types of hybridizations: there are various types of hybridization involving sp-d orbitals or orbitals. The different types of hybridization are as under sp hybridization. This types of hybridization involves the mixing of s and or 1p orbitals, resulting in the formation of two equivalent sp hybrid orbitals. The suitable orbitals for sp hybridization are s and pz. If the hybrid orbitals are to lie along the z-axis, each sp hybrid orbitals has 50% s character and 50% p character. Such a molecule in which the central atom is sp hybridized and linked directly to the two other central atoms possesses linear geometry. This type of hybridization is also known as the diagonal hybridization. The two sp hybrid point of the opposite direction along the z-axis with the projecting positive lobes and very small negative lobes, which provides more effective overlapping, resulting in the formation of stronger bonds. Example of molecule having sp hybridization: as you know, the BeCl2, the ground state electronic configuration of Be is 1s2, 2s2. In the excited state, or one of the second s electrons is promoted to vacant 2p orbitals to account for its bivalency. 1, 2s and 2p orbitals gets hybridized to form two sp hybridized orbitals. These two sp hybrid orbitals are oriented in opposite direction, forming an angle of 180 degree. You will see the angle is very important. Each of the sp hybridized orbitals overlap with the second p orbitals of chlorine axially and form two BeCl sigma bonds. This is shown in figure 4.10. You will see here propagated formation of the sp hybrids from s and p orbitals, formation of the linear BeCl2 molecule. sp2 hybridization. In this hybridization, there is an involvement of 1s and 2p orbitals in order to form 3 equivalent sp square hybridized orbitals. For example, in BCl3 molecule, in the ground state electronic configuration of central carbon atom is 1s square, 2s square, p2p. 1 in the excited state, one of the second electron is promoted to vacant 2 orbitals, as you will see here photographs, and sp square hybrids, formation of the sp square hybrids, and BCl3 molecule. A result, boron has 3 unpaired electrons. These 3 orbitals, 1s, 2s, 1, 2s and 2p hybridized to form these sp square hybrid orbitals. The 3 or hybrid orbitals so formed are oriented in the trigonal planar arrangement and overlap with second p orbitals of chlorine to form 3 BCl bonds. Therefore, in BCl barium, as you will see here, the boron chloride, BCl3 figure 4.11, the geometry of trigonal polar and CiBCl bond angle of 120 degree, 4.11 in previous page you will see. And here the sp3 hybridization, here you will see boron, as you know, the 3 BCl, boron and chlorine is seen is being seen here. So, and the sp3 hybridization, you will see here, this type of hybridization can be explained by the taking example of Cl4 molecules, in which there is a mixing of 1 s orbitals and 3 p orbitals of the valence shell to form the sp3 hybrid orbitals to equivalent energies in SAP. There is 25% s character and 75 p character in each sp3 hybrid orbitals. You will see here, and in next session I will discuss a lot more regarding this sp3 hybridization. Till then, thank you very much.